When you build a complex system relying entirely on how things look, you introduce microscopic errors. Gravity exploits those errors, and the structure collapses. There is an alternative to this trial and error approach. It is called first principles, a framework that replaces visual guesswork with a chain of pure deductive reasoning. This chart shows the structural hierarchy of that framework. It starts with simple, undeniable definitions at the base and stacks them step by step to form complex, unassailable propositions at the peak. To see this in action, we have a specific goal. This diagram shows a single line segment, AB. We need to construct a perfectly precise equilateral triangle on top of it. To ensure the result is perfect, we have one rule. We cannot use physical measuring tools. No rulers, no protractors, and no estimation. By stripping away our physical tools, we force ourselves to rely on structured logical rules. If the logic is sound, the resulting shape is guaranteed to be flawless. First, we need our raw materials. These are our definitions. Definition 1 establishes the point, and Definition 2 establishes the line. These are the irreducible facts of our workspace. Next, we look to our postulates, the laws of motion allowed in this space. Postulate 3 gives us the ability to anchor at any point and draw a circle of any size. Finally, we have our axioms, or common notions. Axiom 1 is the most critical, the law of transitive equality. If A equals B and C also equals B, then A and C are identical. The balance remains perfect. These three components are our only valid tools. Most complex problems fail because we try to skip these fundamentals and jump straight to a solution that looks right. We use postulate 3, anchoring at point A with radius AB to sweep a circle. We mirror this at point B. Because these circles overlap, they create a new undeniable location, point C. We did not have to search for this point or estimate its height. We generated it using intersecting data fields. This is how deductive logic works. It doesn't look for answers. It creates interlocking environments that force the correct answer to exist. We connect points C to A and B. To prove this equilateral triangle, we note lines CA and CB both equal base AB, as they are radii of our circles. Applying axiom 1, all three sides are perfectly identical. QED. We have finally reached a proof. Because we equated every side through a chain of rules rather than a physical ruler, the structure is mathematically unassailable. This exercise was a demonstration of a process. We identified undeniable facts, applied a series of if-then rules, and derived a result that cannot be wrong. This methodology is how we manage complexity. Whether you are debugging software code or stress testing an engine, you are doing the same thing, breaking a problem down to its definitions, the things you know for certain, and chaining them together until the solution is no longer a guess, but a derivation. The next time you face a difficult decision, look past your assumptions. Find your absolute postulates, because a system built on a foundation of logic never collapses.